Okay. Home stretch, guys. Home stretch. You can do it. All right. We finished all the material last day. We had to kind of bump back and go to the binomial again, but today we'll start our review. And so first thing I want to do is just go through and give you an idea of the format of the final exam. And then we'll start and go through, I don't know if you guys saw, I posted practice tests. There's 3 practice tests with solutions, just to give you an idea of kind of what to expect for the final. You know, there's parts of some of them that I'm kind of like, oh no, that's not really something that we did. But don't worry, everything that's on the final is something that we've done. So if you're looking at those practice tests, because those were just compiled to go with the final. So some of the stuff is going to be kind of like, oh, I don't really remember doing that or emphasizing that, but that's okay. We'll just work through it. And I promise on the final, everything should look pretty familiar. Okay. So, oh, that's what I was going to check. Does anyone know what room we're scheduled in for the final exam? Yeah. 308 and 309. Okay, so that's you guys. I've also got H115 at the same time. So I think I'll put everyone in H115 because it's big enough. And there's only one of me and not 3 of me. So I'll put an announcement out on Moodle, but I'll just put it here too. So the final exam is on April 15th at 9. In H115. Okay. We will not use E308, E309. I've had to bring in my sister sometimes to invigilate exams because I'm split across rooms and I can't merge them. But this time, because H115 is big enough, I'll just put everyone in there. But like I said, I'll put in an announcement. Okay. All right. So, first exam slot, the exam season. It's pretty fun. Maybe more for me than for you. Well, it's nice to get it over it. All right, so the final exam format. There's going to be 5 true, false. Now for those true, false, and then there's going to be 15 multiple choice / kind of short word answers. For those, kind of anything goes. I wouldn't really hinge on any of the practice tests for those. Just use the practice tests to give you an idea of the types of questions that could be on there, right? But you have to study all the theory, especially from the first few chapters, right? And so there's a lot of kind of theoretical things, and that's what makes true, false, and multiple choice really difficult, right? Because you really have to know the theory that goes into it. So true, false, and then 15 multiple choice and short word answers. What I mean by short word answers, it could be something like, give an example of a numerical variable, right? And then you just give something, speed, distance, length, right? Anything like that. Okay. So I'm not gonna focus too much on those 20 questions, right? This is all gonna be theory from chapter 1 and 2 mostly. For the long answer, so these are kind of the short answers, and then we get into the long answers. Question 1 is going to be one of those 5-number summary. Are there any outliers? And then you're going to have to draw a box plot. Like I've complained about this before. It's a common final, so I didn't make it. So we're just going to have to roll with the punches. But we'll draw a box plot today, and you'll see we did one or two even in class, and so they're not that bad. But it's going to be a 5-number summary. Find any outliers and draw a box plot. I noticed in all the practice finals, the next question is the binomial. So just to match the practice final, I'll switch the order in the actual final and to match this. So question 2 is going to be a binomial question with a normal approximation. So we just did that last day. And then there's practice. You didn't have to do it for assignment 3, right? But it's the last question on assignment 3. And there's solutions to that posted, so you can go through and have a look at those. And then question 3 is going to be a tree diagram, right? So from probabilities and find probabilities. Yeah, so I'm the one marking it. So just do what I've taught you. It does make it easier. It'd be tricky if other people were marking it. And then I can't remember if we had any Z scores on test 1. No Z scores? Seeing some shakes. No? Did I bump it all to test 2? Anyways, I think there were some Z scores. So question 4 is going to be a Z score question. Z scores to find probabilities. Should have made a note on here. So everything from here on up is from test number 1. And assignment 1, assignment 2, and assignment 3. The true false multiple choice are mostly from kind of test 1 stuff. There's maybe a couple, like if the p-value is larger than the alpha level, what are you going to do? That kind of thing. So just a sprinkling from later stuff, but mostly test 1. Okay. Any questions or any other questions so far? So far, so good. Okay. Here's where I get a little sneaky, a little vague. 5 and 6 and 7 are going to be from the means sections, right? So we have 4 different types of means problems that we can do. We're only doing 3 of them. I'm not going to tell you which ones, right? You have to study all of them, just like on test 2, right, where you had a bunch and you had to figure out which ones. Now you have to do all of them, of course, but on the plus side, there's only going to be a hypothesis test or a confidence interval, right? And so it's not going to be both like it was on test 2 or even on the assignments, right? It's just going to be one or the other. So it's going to be a hypothesis test, which from here on out I'll abbreviate HT, or a confidence interval, which I'll abbreviate C. From one sample mean sigma known, or one sample mean sigma unknown, matched pairs, or 2 sample means. I'll throw in independent here, just to emphasize. Okay. So there's 3 of those questions, right? From those 4 types, only a confidence interval or a hypothesis test, and it'll be clear which one to do, right? Mostly because a confidence interval will say, make a confidence interval. Right? So you'll know. From 8 and 9, same idea. Right now we're moving into proportions. We've got 1 sample proportion or 2 sample proportions. And so it's going to be a hypothesis test or a confidence interval from 1 sample proportion or 2 sample proportions. And a sample size calculation. Right, so we did a sample size calculation on the assignment 6, and a sample size calculation. Oh, I forgot to do a little cutoff after question 5, 6, 7, right? Because that was on test 2. So test number 2 and assignment 4 and assignment 5. So 8 and 9 are from assignment 6. And then last question is on regression. So question 10 is a regression question, which I think everyone kind of enjoys a little bit, right? So that's where we have to find the correlation. We have to find the regression equation, right? Which means finding the slope, finding the intercept. And then I'm going to keep it on there. We're going to draw the regression line just because why not? And then we're going to use our equation to predict a new value. So very similar to what you did on the assignment. Nothing too crazy. So we have to find the correlation. Right. Given those 5 pieces of information, right? The 2 means, the 2 standard deviations, and the covariance, you can find the correlation. Find the regression equation. Least squares regression line is the technical term. Least squares regression line. And that's more as a note for the practice finals, if you're looking at those and you see LSRL, least squares regression line. So find the regression equation, meaning just find the slope, find the intercept, put them together in the regression equation, and then draw the LSRL, least squares regression line. Now that I've defined it, why not use it? And then predict a value of y given a value of x. I'll say that. Given a value of x. You have to keep track of, okay, so is this x value within the range of my data, right? Or is it, if it's outside the range of my data, then you have to be more careful, right? Because then you're extrapolating, making your prediction less reliable. Okay. So this is from assignment number 7. Any questions? Yeah. You bet. So what we're going to do today and on Wednesday is we're just going to work through practice test number 1. I just figured I'd pick one. First one seemed logical. But then remember, there's 2 more that you can do with solutions. And I want you to, like I said, some of those questions are not something that you need to worry about, right? So if you're looking at a question and you're like, oh man, this looks so foreign, then you can just send me a picture of it and say, hey, is this something that I need to know? And then I'll tell you yes or no. Okay, so I don't want you to be struggling through this stuff because some of those questions are not relevant to stuff that we've done, right? And that's just because we all teach different, well, we teach the same stuff, right, but with different emphasis, and so that's why they'll be a little bit different. Okay? But like I said, you'll be prepared for the final. Any other questions? Okay. So what I'll do is we'll just do, so practice test number 1, it's the one that we're going to go through. We're not going to go through the true, false, or the multiple choice short answer solutions, just because, like I said, those are going to change, and I don't want you hung up on a specific set of questions for those ones. Okay, so not going through the true, false, or multiple choice. The solutions that are posted have little justifications for why it would be each question, right? And so that's why I'm not spending too much time on those. But what I do want to do is just start with the long answer. So we've got 13 data points, and I guess we can flip back. You haven't seen it. First thing we're going to do is create a split stem and leaf plot, which is not something that we emphasize. It's something that we did, but I'll tell you this, it's not on the final, so we'll do it, but don't worry about it. So that's kind of a prime example of things that are in some of the practice tests, because sometimes people do it, but we don't have to worry about it. Part B, we're going to have to describe the overall shape of the height data using this stem and leaf plot. But then, right, I said we have to do a 5-number summary. We have to find if there's any outliers, and we have to draw a box plot. So part C, D, and E, those are the ones that are important for this. We'll do all of them, but just as a heads up. So first thing that I'm going to do, right, first for the stem and leaf plot, but also for my 5-number summary, I have to sort my data. Just go through and sort this data. So sort the data. And I've got it pre-assembled here. So we've got 58, but it's a good idea as you list the number, right, just to check it off or something, make sure that you don't have any duplicates or that you're missing one, and then finally when you're done, make sure you have the same number of data points, right? So 58, 59, 60, 61, 65, 65, 66, 67, 72, oh, running out of room here, 73, 74, 77, and 79. Not ideal to not have enough room, but whatever. So looking at these, remember our stem and leaf plot, we had our stem, which is going to be our 5, 6, and our 7. And a split stem and leaf plot just means that we split our 6 and our 7. Well, we split our 5 too, I guess. 5, 6, 7, 7. Like I said, not something that you need to be concerned with. So a split stem and leaf plot, because the rule is that you have to have at least 5 stems. And so when we did it, we only had 5, 6, and 7. So that's only 3 stems. And so then what we do is we say, okay, well, anything with a leaf from 0 to 4 goes on the lower stem, and then we split it. And then the higher leaves, right, 5 to 9, go on the next stem. So the starred stem, I guess. So we've got 58 and 59, so those would go on your upper stem, so 8 and 9. 60 and 61 would go on your lower stem for 6, and then 65, 65, 66, 67 would go on your upper stem for 6. And so we've got 0 and 1. Making sure that you stack your numbers so they're taking up the same amount of space. Right? Thinking about, okay, we're trying to make a fake histogram here, and so we have to have all these numbers stacked on top of each other. So then 5, 5, and then 6 and 7. And then for the lower stem for 72, 73, 74, so 2, 3, and 4. And then the upper stem for 7, we've got a 77 and a 79. If you kind of tilt your head here, looking at sideways, this looks like a histogram, but also looks like it follows a normal distribution. So I'll just do this. So part B, oops. Describe the overall shape of the height data. Approximately normal. I'll throw in the center, centered around 65-ish. And the spread from, well, here we have the numbers from 58 to 79. This question was only asking about the shape, so I threw in the center and spread just because we can. But it's approximately normal, and the solutions have things like unimodal, bell-shaped, roughly symmetric. But if you just say approximately normal, well, that's good. So like I said, those ones, yeah, we did them, and if you go back into the archives, you know how to do them. But here's kind of where the important stuff starts. So part C, describe the data using a 5-number summary. So we give a 5-number summary. Remember, a 5-number summary is the minimum, Q1, the median, Q3, and then the maximum. So we've got the minimum, we need Q1, we need the median, we need Q3, and the maximum. The minimum and the maximum, we've already sorted our data, right? So that's easy enough. 58 and 79. For our quartiles, right, we're gonna count in, so use the boop, boop, boop method just to count in. Kind of tricky because I'm on 2 levels. So start here at 58 and 79, boop, boop. boop, 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 boop. All right. I landed on 66 as my median. If you'd landed on two numbers, or you'd have to take the average of those two, and the median would actually be in the middle of those two. Right? And so where the median is depends on, or tells you how to find your quartiles. Right? So now, because we've used 66 as the median, we can't use it to find our quartiles. Okay? So we'll jot down 66 here. But now our first quartile, we just find essentially the median from 58 to 65. So, oop, oop, oop. And to show that we're taking the average of two values, we'll say Q1 is 60 plus 61 divided by 2, which is 60.5. And then same thing for the third quartile. We can't use 66. So we use 67 to 79. Boop, boop. So Q3 is 73 plus 74. Oops. Said 74, but wrote 75. Divided by 2 is 73 and a half. You can see how important it is, right? This was a while ago that we did these, or it was a long time ago, right? But it's important that you remember to sort your data before you try to find your quartiles. So there's your 5-number summary. Great. Part D. Are there any outliers? Justify your answer. So for outliers, right, we have to find the lower bound and the upper bound. The lower bound, remember, is your first quartile. So from your first quartile, you're going to go down 1.5 times the interquartile range. So Q1 minus 1.5 times the interquartile range. Your interquartile range is Q3 minus Q1, which in this case is 73.5 minus 60.5. It's so early. 13. So your lower bound is going to be Q1, which is 60.5 minus 1.5 times 13. 1.5 times 13. So 60.5 minus 19.5. It's 41. So now we check, are there any values below 41? If there are, they would be outliers, right? But since the minimum is 58, there are no values beyond the lower bound. Since the minimum value is 58, there are no values beyond the lower bound of 41. We'll do the upper bound now. So the upper bound, same idea, right? But we start from the third quartile and now we're going up 1.5 times the interquartile range. So the upper bound is Q3 plus 1.5 times the interquartile range, which is 73.5 plus 1.5 times 13, 73.5 plus 19.5. 93. The maximum was 79, so all the data points are within the bounds. Since the maximum is 79, there are no values beyond the upper bound. Oops. (93). Therefore, there are no outliers. Part E, we're going to draw a box plot. Box plot is just a visualization of our 5-number summary, showing if there's any outliers, if we found any, right? And so what we have is, I'll draw a horizontal box plot here. Just draw a quick little number line here, start at 55, 60, 65, 70, 75, 80, something like that. Just a quick sketch. So the first thing, remember to do when you're drawing your box plot is you're going to draw a line at the median, right? Because the box in the center, that's the first quartile, the median, and the third quartile. Those are going to stay the same regardless of if there are outliers or not. And so you're going to have, okay, so the median is at 66. So I'll draw a line roughly here at 66. Oops, 66. And then I think Q1 was 60.5 and 73.5. So roughly here at 60.5, got Q1 is 60.5 and 73.5. Q3 is 73.5. Connect those quartiles to make a box. Here's where you would draw your whiskers to your values, the last values that are inside the lower and the upper bound, right? And then if there are values beyond there, you would indicate them with a star. So for us, right, we've got our kind of lower bound of 41 and an upper bound of, what was it, 93? Somewhere way out here. Upper bound is 93. Our minimum and our maximum are within these. So our minimum was 58. So we just draw a shorter line at 58 and then attach it to make that whisker. And our maximum was 79. Yeah, 79. So we draw another whisker at 79. Let's say the max is 79. drawn a box plot.
Do you care if we draw them vertically rather than horizontally?
No, it's just a space issue. Yeah. Because well, especially because there's these first two questions on here. So I think you'll end up drawing it horizontally, but if you want to do like a mini vertical one, that's fine by me. Any questions? Oh. It was a while ago, but pretty reasonable, I think. You can do it. So, question 2 is where I kind of switcherooed the order. Well, not for you guys. It's going to be the binomial. And so, a particularly well-known restaurant chain and Canadian icon offers a chance to win prizes on every cup of coffee between February 6, 2019 and April 17th, 2019. I'm curious if those are the actual dates. We'll see, I guess. Or I guess we could find out. According to contest details, the chances of winning a food prize are 1 in 6. Okay. So in a random sample of 12 coffee cups, what's the probability of having exactly 3 food prize winning cups? Right, so we can use the binomial distribution, right, because we've got success, failure, right? You either win on a cup or you didn't win on a cup. Right? There's no other options, and so you can use the binomial because the probability of a success is 1 in 6, so 1 out of 6. So we'll use the binomial distribution, but I'll just read through the question to give you an overview. Part B, we're going to use the binomial, but for more probabilities, right? What's the probability that you get 3 or fewer food prize winning cups if you have 12 cups of coffee? And then during the contest window, suppose that you spend 66 days traveling across Canada and buy 1 cup of coffee each day from one of these well-known restaurant chains. Use the normal approximation, make sure to test the conditions to find the probability of winning 17 or more food prizes out of the 66 trials. Right, so that's where we're going to use the normal approximation, which we only just introduced last day, but that means it's nice and fresh. Oh, the little number in the box, that's just the number of marks available. Oh. There. So what we have is the probability of success is 1 in 6, which if you wanted to is 0.166 repeating, right? You can keep that, but you have to keep all the decimal places. Right. So must keep all decimal places. So whether that means you're storing it in your calculator or working with a fraction, the exact value, then it's up to you. So we've got the probability of a success is 0.166 repeating, or 1 in 6. And we've got N is the number of trials, which in part A is 12 coffee cups, right? So we buy 12 cups and we roll them. Hey, it doesn't say if we roll them. I assumed. How else would you win? You scratch them? No. although that'd be fun. So you roll them. And what's the probability of having exactly 3 winners, right? So not less than 3, not more than 3, just exactly 3. So then we have to use our binomial distribution. And so we want K, which is the number of successes. We want it to be 3. So the binomial distribution says that the probability that x equals k is n choose k times the probability of a success to the power of k, the number of successes, times 1 minus p, which is the probability of a failure, to the power of n minus k, which is the number of failures. In our case, we've got 12 choose 3. The probability of a success was 1 in 6 to the power of 3. 1 minus 1 in 6 to the power of 12 minus 3. Remember how to do 12 choose 3 on your calculator? We just introduced it last day, so might not be that familiar, right? But you're going to use this is 12 choose 3. And so on, well, at least on this calculator, I just do 12, and then the NCR is the second option over the plus sign. So second NCR, and then 3 equals, and I get 220. So there's 220 ways that I can have exactly 3 successes in 12 trials. So 220, and then 1 divided by 6 to the power of 3. I get 0.00462963. And at this point, as long as you're keeping all 9 decimal places, you're okay. 5 over 6 to the power of 9. Point 193806699. Oh, I should have stored the previous. If I multiply these out, I get 0.197395712. You can leave it like that. Why not? Or if you want to rounding to 4 decimal places, the probability that x equals 3, right, exactly 3 successes, is roughly 0.1974. Any questions about that one? Okay. Then let's go to part B. So in a random sample of 12 coffee cups, what's the probability that you get 3 or fewer food prize winning cups? Right. So that's the probability that X is less than or equal to 3, right? Because 3 or fewer, which is the probability of 0 cups, right? So you don't want to forget about 0, right? Because that's kind of a sneaky one. So 0 winners, 1 winner, 2 winners, or 3 winners. So that's going to be the probability that X equals 0 plus the probability that X equals 1 plus the probability that X equals 2 plus the probability that X equals 3. We just did the probability of X equals 3, so we don't have to do that one again, right? We can just steal it from part A, but we do have to find 0, 1, and 2, and then add them up. The probability that X equals 0 is 12 choose 0 times 1 and 6 to the power of 0 times 5 and 6, oops, because 1 minus 1 and 6 is 5 and 6 to the power of 12. If you do 12 choose 0 on your calculator, you'll find that it's just 1, right? There's only one way to have 0 winners. 1, and then anything to the power of 0 is 1. So the only one we're concerned with is 5 over 6 to the power of 12 times 0.112156655, which is just the probability. 0.112156655. I'm going to make a note that I'm storing this in 1. That's more for me than anything else. Or maybe I should store it in 0. Aha. For X equals 0. So now we go on and we find the probability that X equals 1. 12 choose 1 to the power of 1, or times 1 over 6 to the power of 1 times 5 over 6 to the power of 11. Just kind of cutting corners a little bit, because I know the powers have to add to 12 always. So 12 choose 1 on your calculator. You'll find that there's 12 ways of choosing exactly 1. And so 12 times 1 over 6.166, repeating. And then 5 over 6 to the power of 11 is 0.134587986. Which is 0.269175971, which I'll store in 1. Same idea, the probability that X equals 2 is 12 choose 2 times 1 over 6 to the power of 2 times 5 over 6 to the power of 10. 12 choose 2 is 66. 1 and 6 to the power of 2. 0.02777. Repeating. 5 and 6 to the power of 10, 0.1615055583. Oops. Once I multiply those through, I get 0.296093569, which I'll store in 2. And then recall that the probability that x equals 3 was, I may as well keep all the decimal places because I forgot to store it. 1/6, oops, to the power of 3, 5/6 to the power of 9. Point 197395712. Store that in 3. So now the probability that x is less than or equal to 3 is the probability that x is 0 plus the probability that x is 1 plus the probability that x equals 2 plus the probability that x equals 3, which is recall 0.11215665 plus recall 1.269175971 plus, I'll jump to the next line, recall 2.2960935569 plus 3 197395712. Recall 0 plus recall 1 plus recall 2 plus recall 3. I get 0.874821907. And I may as well just leave it like that. Tedious, but not hard, right? Once you kind of figure out which probabilities you have to find, it's just got to get to work and find them. Make sure you know if your calculator has a store function, make sure you know how to use it. It should have some sort of store function. Most of them do. Any questions about that one?
I'm just confused where you're getting 5/6.
Oh, it's because it's supposed to be 1 minus 1/6, but 1 minus 1/6 is like 6/6 minus 1/6, so 5/6. Yeah, sorry, I shortcutted that really fast. Six over 6 minus 1/6. It's 5/6. Any other questions about that one? So now, in part C, you've got 66 days, so 66 cups essentially. I don't know why we had to be traveling across Canada. Maybe it's just for fun. Maybe it's for a random sample. I don't know. And you buy 1 cup of coffee each day from one of these well-known restaurant chains. Use the normal approximation. Make sure to test the conditions, right? And to find the probability of winning 17 or more food prizes during your trip across Canada. Right, so we've got n is 66, right? The number of trials is 66. And we want k to be 17 or more successes. If you think about, okay, you definitely could do it on your calculator just like we did before, right? But that's the same as finding the probability of 17, 18, 19, 20, blah, 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 all the way to 66. Sounds terrible. Even if you use the shortcut of taking, okay, well, that's the same as 1 minus 0, 1, 2, 3, all the way up to 16, you'd still have to find 17 probabilities, and it just sounds terrible. So what we do is we check the assumptions and we say, well, at least we have to have at least 10 expected successes and at least 10 expected failures. And then we can use the normal approximation. Okay. So how do they, so the conditions are the same as the ones we had for the proportions, right? So we have to have at least n times p has to be greater than or equal to 10. And n times q has to be greater than or equal to 10. In our case, n times p is 66 times 1 over 5, or sorry, 1 over 6. Which is 11, which, phew, is greater than or equal to 10. N times q is 66 times 5 over 6, which is 55, which is also greater than or equal to 10. So now we can use the normal approximation. Therefore, we can use the normal approximation. Which says that, okay, well, mu is n times p, right? And these are the ones on your formula sheet. So mu is n times p, which is going to be 66 times 1 over 6, which we already decided was 11, right? So now we have a mean of 11. And sigma is the square root of npq, which is the square root of 66 times 1 over 6 times 5 over 6. Which is the square root of 9.166 repeating. So I've got 3 point, you don't want to forget that square root, 3.027650354. Or roughly 3.028, say. So now we know mu and we know sigma. So now we can calculate, okay, well then z is x minus mu over sigma. And in terms of a graph, right, if we're saying, okay, well, the conditions were met. So now we've got a normal distribution and we found the mean to be 11 and sigma to be 0.3028. And we want the probability of 17 or more. So 17 is going to go somewhere here, and or more is the area above. So this is the area that we want. So now we're back to those very kind of basic z-score calculations where we use the z-table to find the area under the curve. So Z is 17 minus 11 over 3 point. I have a little typo here. Actually, it's kind of a big typo. 3.028. So 17 minus 11, 6 divided by 3.028, 1.98150595. Z scores have to be rounded to 2 decimal places. 1.98 once we round properly. So now we can use the Z table. So using the Z table, we find the area to the left, right? We always start with the area to the left, and then if we want the area to the right, we have to go ahead and find it after. Of Z equal to 1.98 is positive, so we have to be on the positive side. 1.98, the area to the left is 0.9761. So the area to the right is 1 minus 0.9761. 0.0239. Therefore, the probability of winning 17 or more prizes, or sorry, food prizes, in 66 trials is 0.0239. Any questions about that one? Okay. Then we'll move on to question 3. So for more practice with that one, right, because we haven't done it, you haven't been marked on anything of it, right, but have a look at assignment 3, but also test 1, it was that huge bonus, right? I said we didn't have time to cover it, but if you read up on it, then you can still do it. So question 3 is a probability question. So we'll just have a read through it. Should look pretty familiar, right? So you're running a daycare and you have 5 infants and 8 toddlers. Suppose 3 parents at random pick up their children. So build a tree diagram for picking up 3 children. This one has 3 layers, right? Because parent 1 comes and picks up their kid and it's either a toddler or an infant. Parent number 2 comes, and then parent number 3 comes. This one has the added complexity of, okay, well, if one kid's gone, right, the probability changes a little bit, right, depending on who was picked up previously, right? So we have to take that into account, but we'll have a look, and it's not that bad. And then you're going to find some probabilities. What's the probability that all 3 children are toddlers? What's the probability that at least 1 child is a toddler? And then at least 1 child is a toddler. given that there's at least one child who's an infant of these three. So we'll start with building the tree diagram. So here, we've got a total of 5 plus 8, oops. So 13 children. I'll start with the first parent picks up their child and it's either an infant or a toddler. The probability of it being an infant, right? This parent has 13 kids to choose from. Well, not really choose, but picking up one of 13 kids, right? And so there's 5 infants, so the probability of picking an infant is 5 and 13, and 8 toddlers, so the probability of a toddler is 8 and 13. Then the second parent comes, kind of depends on what happened with the first parent. But they'll either pick up an infant or a toddler or an infant or a toddler. Now there's only 12 kids left. So only 12 children left. So all these probabilities have to be out of 12 now. One of the infants are gone, right? So there's not 5 infants, there's 4 infants. So 4 out of 12 are infants. There's still 8 toddlers. If the first one picked up was an infant. If the first child picked up was a toddler, then there's still 5 infants at the daycare, right? So 5, but now out of 12. And if the first one was a toddler, then there's 1 less toddler, so then there's 7 out of 12 toddlers. Same idea. You've got the third parent. Now there are only 11 children left. Squeezing it in there. So each of these branches gets their own set of branches. Clean that one up. And it's either an infant or a toddler, an infant or a toddler, an infant or a toddler, infant or a toddler. Doesn't help that I's and T's kind of look similar. You don't watch yourself. Right, so now all these probabilities are out of 11, right, 11 children. So now there's 1 less infant if we're just going down the left-hand side chain, right? First an infant, then an infant, and then the third infant. So now the probability of the third infant is 3 out of 11. None of the toddlers have been picked up on this first branch, and so there's still 8 out of 11 toddlers. Second set of branches, 1 infant and 1 toddler have been picked up, and so we've got 4 out of 11 and 7 out of 11. Same thing, but kind of reversed for the third branch. 1 toddler and 1 infant have been picked up, And so there are now 4 out of 11 and 7 out of 11. And for the final set of branches, none of the infants have been picked up, so it's 5 out of 11. And 2 of the toddlers have been picked up, so 6 out of 11. So here, we can find the probabilities at the end of each branch, right? And what we do is we just multiply down. Right? And so there's not a lot of room here. I'll just label them 1, 2, 3, 4, 5, 6, 7, and 8. And what I want you to do is just go through and do those on your own, and then that's where we'll start. I'll just give you those at the start of next day. Won't sit here and calculate them. Okay. So any questions before we wrap up? All right. We'll keep working through this practice test on Wednesday. If you didn't get your assignment, come grab it here.